Hello guys, my name is Narasak Khun and I'm a sophomore majoring in industrial engineering at Paragon University. So in this video I will be showing you how to solve this exercise 7.7 in a software called PermaLearn.xyz. So let's start by reading the problem. So they want us to determine the internal normal force, shear force and moment at point C and point D, which is from the diagram we can see that we have a long beam that is 6 meters and we have two support. At A we have pin support and at B we have a roller, and we also have two force acting on the beam. So let's start by creating this in our software. So before we start, we should check the grid size, make sure it's bigger than our beam. Okay, 10 by 10. Okay, so our beam is 6 meters long, so 10 by 10 is okay. And for mesh size, I will use 0.5. I will tell you why I use 0.5 later on. And unit system is in SI. So let's begin by creating our member. So I usually started at this point, so my begin coordinate is 0 and my coordinate is also 0. And the horizontal distance would be 6 meters. Okay, there we go. Okay, so we got the beam. Now let's create the support. So first at point A, we click on this and we go at point A, it is a pin support, so we click on pin and then add. Okay, so now at point B, which is at the far end over here, at point B is a roller, so let's roller add. Okay, so now we have both pin and a beam, and we needing two more force. So let's start with the 5 kilonewton force. The distance from beginning, so this force is 3 meters from A, which is our beginning point, so it's 3 meters. And horizontal force, no, since it's a vertical force, is -5, because the direction should be downward, and in this system we put it as upward, so if we add negative it will be pointing downward. Okay, so let's add. So we also have another load, so let's add. It's on member 1, there's only one member, and our load type is in vertical, and the distance it starts from the beginning point, so it's 0, and the end distance from the end point, so we want to find this distance from here to here, so it's 3 meters, because our load is from here to here, and the distance from the end point of this load would be 3 meters, because it's on the beam right now. And our begin load is 3 kilonewton and -3 because it's downward, and our end load will be 0. Okay, so now we got the two support and the two force and the two load, and we have the beam, so everything is ready. So let's go to solution. We want to find the normal force, shear force and moment, but let's start with the normal force. So normal force, display, wait, it should be 0.5. Save. I choose 0.5 here because as we can see here, there's like more point on the beam. Like every 0.5 meter, there's a point where we can click, we can hover our mouse on it, and it will show us the normal force and so on. So at point C is 1.5 meter from the beginning point, so it's here. So normal force over here is 0, and at point D over here, normal force is 0 also. Okay, let's move on to the next one, shear force and display. Okay, so at point C over here, we have our shear force 2.875, and at point D we have minus 3.25. Okay, so let's move on to the last one, the moment, bending moment, display. Okay, so at point C we have bending moment equals 6.5625, and at point D we have 9.75. So that's all the solution for this exercise, and yeah, that's it.